In this video, we will be talking about combining like terms. Consider the expression 3x plus 2x. Now, what exactly does it mean to combine the like terms in this expression? Well, first off, the like terms in this expression are the x's. And to combine them, we are simply adding their coefficients together. 3 plus 2 is 5x. And the reason that this works is because, well, if you have 3 of something and you add 2 more of that same something, then you will get 5 of that something. In this case, we represent the something as the x's. And that is what makes the x's like terms. We can standardize this rule as ax plus bx equals a plus b times x, where if you have a variable such as x, where they are like terms of each other, you simply just add their coefficients together. Let's consider another example. Combining like terms can also apply to subtraction. Let's say we had our similar original expression, except it was 3x minus 2x. The way we would solve this, instead of doing 3 plus 2, we would have 3 minus 2. You can also think of this as a positive number added to a negative number, which is basically subtraction. So what we have is 3 minus 2 will give us 1x, or just x. If we do the reverse, we have a similar effect. If we have negative 3x plus 2x, again, we can think of this as negative 3 plus a positive 2, or a positive 2 minus a 3. But what we get is minus 3 plus 2 equals negative 1x, or just negative x. What if we had an expression that had more than one type of variable, or more than one type of term? As you can see in this expression, we have both x's and y's. We know that the x's are like terms of each other, and similarly, the y's are also like terms of each other. So, if we combine the like x terms, we do 4 plus 2 gives us 6x. And similarly, we do the same with the y's. Remember, if you have a variable such as this y that's on its own, that's the same thing as having just a 1 in front of it. So 3y plus 1y will give us 4y. And here we have our simplified expression with combined like terms. Now, let's consider this expression. 5x squared plus 3x plus 4x squared plus 2x. So here we have the terms of x squared and x. Now, even though these terms both have an x in them, there are not like terms because of this exponent. This exponent makes them unlike terms. So we treat it like the x and y expression that we had, where the x and x squared are different terms. So to combine like terms in this expression, we do 5x squared plus 4x squared, which will give us 9x squared, and then the 3x plus 2x, which gives us 5x. So the takeaway from this problem, from this expression, is that exponents can make two terms unlike each other, can make them non-like terms. So an x squared and an x are not like terms. Which means that they cannot be combined in this way. Now this rule of combining like terms can work with any kind of term, whether it's an x, a y squared, or an x squared. It can also, however, expressions, whole algebraic expressions, can also be their own terms. So if we have something like 3 times the square root of x over x minus 1 plus 7 over the square root of x over x minus 1. Now, this may look like a very gross, disturbing expression, but if you notice, you'll see that what lies within these parentheses are the same thing, which makes them like terms, which means that we can simply do 3 plus 7 will give us 10 times what lies within the parentheses. Because again, these two things are like terms as they are identical expressions, which means that they can be combined as like terms. Now let's try a more complicated seeming problem. 4 over 3x plus 1 over x. Is there a way of combining these two terms in a way that will simplify this expression? Well, as you can see, what we have are two fractions being added to each other. And if you remember your fraction addition rules, in order for two fractions to be addable, we need them to have a common denominator. Basically, the denominators on the bottom of each fraction need to be the same, which would then allow us to add the numerators to each other. This is basically the same thing as combining like terms, except in this case, the like terms are simply the denominators of fractions. So how would we give these two fractions common denominators? We'll do that by multiplying the bottom of this fraction times 3 and the top of the fraction by 3. And what we get is 4 over 3x plus 3 over 3x. Notice that these are now common denominators, which makes them like terms, which means that these two numerators can be added together. 4 plus 3 is 7 over 3x. And that is our final solution. We found common denominators of x, and using those as like terms, we were able to add the numerators. So the idea of combining like terms can be represented by this general expression. ax plus bx equals a plus b times x. And in this expression, a and b are simply coefficients, which are just numbers, and the two x's are like terms, and they can be x's, they can be x squareds, y's, y squareds, they can be a crazy fraction or some crazy complicated expression, but as long as these two x's are the same thing, they can be added together in this way. They are like terms that can be combined.